Welcome to aminacademy.com and engineering mechanics regarding velocity of a piston of a reciprocating pump. Let us solve the problem. Example, in a crank and connecting rod mechanism, the radius of the crank and the length of the connecting rod are 300 mm and 1200 mm respectively. The crank is rotating at 200 rpm. Find the velocity of the piston when the crank is at an angle of 45 degree with the horizontal. Now, here theta is 45 degree. Connecting rod length is 1200 mm and the crank is 300 mm. Now, radius of crank are equal 300 mm, which is equal 0.3 meter. Length of connecting rod L. Length of connecting rod is 1200 mm equal 1.2 meter. And angular rotation equal n equal 200 rpm. Therefore, we can write omega 1 angular velocity of crank omega 1 equal 2 pi n by 60 equal 2 pi n is 200 over 60, which is equal 2 into 3.14, 2 into 3.14 into 20 divided by 6 equal 20.933 radian per second. From the geometry of the figure, we can write sine phi equal, here this is perpendicular distance m, that is bm by bc, bm is ab sine 45. For this, bm is ab sine 45, then over bc is equal, ab is 0.3 sine 45 over BC is 1.2, which is equal 0.1768. Therefore, angle phi equal sine inverse 0.1768 equal 10.18 degrees. 10.18 degrees. Now, velocity of the piston is given omega 1 into L sine phi plus R cos theta into tan phi equal omega 1 is 20.933 equal L is 1.2 into sine phi equal sine of 10.18 degrees plus R is 0.3 into cos 45 degree into tan 10.18 degrees. Now, which is equal 20.933 into 1.2 into sine 0.1768 plus 0.3 into cos 45 is 0.707 into tan 18 is 0.1796. So, which is equal 20.933 into we'll do this 1.2 multiplied 0.1768 plus 0.3 into 0.707 into 0.1796 equal 250,253 equal 20.933 into 0.250253 equal 5.24 meter per second. Therefore, velocity of the piston is 5.24 meter per second. We have done. Please subscribe our YouTube channel.